Welcome to Study Loop.
For part A, just remember that CFT denotes the concentration of the CFS. So we know from this statement that the concentration in 2000 was of 1,915 parts per trillion. So CF 2000 is 1,915. The same for 2014. CF 2014 is 1,640 because that was the concentration that year. Then those are the answers for part A, and then for part B, if we have to compute the derivative, and if we assume that the change is linear, then the derivative is going to correspond to the slope of the line. So C prime of t is the slope of the line, and in this case we can compute that slope. We are going to denote it by m by computing the quotient. So at the top it's going to be the difference between the concentration over the difference in time. So this gives us minus 19.6428571. This must be parts per trillion over years. And this number is the derivative at 2000 as well as the derivative of C at 2014. Since it's aligned, since the change is linear, then the derivative is the same at both points. And then for part C, remember that we can compute the equation of a line with this formula. Y minus y0 equals m times x minus x0. We computed m already, and y0 and x0 is a point on the line. So we can take, for example, x0 to be 2014 and y0 to be 1,640. So we have this minus 19.6428.571 times x minus 2014. And then when we expand this product, we obtain the following. We're going to have here 39,560.7141. And then, if we rewrite this, we obtain y equals minus 19.6428 times x plus 41,200.7142. Okay, and this is the equation of the line we were looking for. Now we can write this as C of t, and the variable is the time. So this is the equation we were looking for. And then in part D, if we want C of t equals 1500, then, and we want to find the time at which this concentration happens, then we only have to solve this equation. And the solution is t equals 1500 minus 41,200.71 over minus 19.64, and you can add the decimals, and an integer approximation of this quotient is 2021. So we're going to take this as the year at which the concentration is expected to be, or was expected to be, 1500. And now for part E, if we knew that the function has a positive second derivative, that is, that the function is concave up, then our answer for part D would be too early. That is, the concentration at 2021 would be much higher than 1500. And that is because we know that the derivative of CFT is negative because the concentration is decreasing. However, if the second derivative is positive, we expect that with time the derivative will be negative, but its value will increase. That is, the derivative will be less negative. And so the change in the concentration will be slower. If we try to make a sketch, we will see that the line that we computed above will be below the graph of the function CFT, and the value of the concentration in the year 2021 would be higher than 1500, and the year at which the concentration would be 1500 would be later than 2021.